Good afternoon. Thank you for joining us for our Container Monitoring Tools Comparison webinar. My name is Jake Malmad. I'm a senior DevOps consultant here at Mission, passionate technologist, musician, and photographer. My background is in cloud architecture, Kubernetes, and all things DevOps. And I'm joined by my colleague, Luke Reimer, who I will allow to introduce himself.
Hi, my name is Luke. I'm a cloud consultant at Mission, based in Colorado, and I do a lot of automation, DevOps type stuff, and watch a lot of basketball.
Excellent. So, just a brief introduction for who we are. Mission is an AWS Premier Consulting Partner and next-generation managed service provider that offers a comprehensive suite of services to help architect, migrate, manage, and optimize in the cloud. And additionally, if you look over at the attachment section on the right, we've included an overview data sheet as well as a container consulting data sheet and a few case studies, including one of the customers we'll discuss today, Your Call Football. So please feel free to check that out after the webinar. Our agenda for today, first we're going to just briefly cover what the market problem is, an overview of EKS and ECS, compare and contrasting different container monitoring tools, customer use cases for leveraging them, and then we'll wrap them up with a brief Q&A. So what is the market problem? In today's world, using containers is a standard practice, and running them on an orchestration platform like ECS or EKS to perform at scale is a large part of why we've seen the increase of container adoption. The typical benefits apply: scalability, high availability, ease of developer enablement. But the decision about which container monitoring tool to use can still be difficult, as up until very recently, Amazon didn't have a native out-of-the-box solution for this. This session is primarily focused around Kubernetes monitoring, but before we get into that, we're going to review the two different AWS container orchestration services, ECS and EKS.
Yeah, so to talk about ECS and EKS really briefly, those are the two primary ways that people are going to use an orchestration tool in Amazon to run containers on EC2 instances. ECS has a longer history with Amazon. It was launched in 2014. It's very scalable, high-performance container orchestration service. It supports only Docker containers, but it's very easy to get up and running, and you can run and scale your containerized applications in AWS. And for a long time, it was probably the easiest way to get going running containers in Amazon and taking advantage of those services and stuff. So very easy to adopt and use when we're talking about benefits. They support Docker Compose. You can also have serverless clusters. It is secure by default. It performs very well at scale, and then has a lot of service integrations like IAM, parameter store, secret manager, and is a great way to optimize for cost in running your containers. So you can scale containers and nodes using ECS fairly easily. There are some limitations, though. In-place updates to your running containers are tricky. It is limited to the Docker model, which we mentioned, so other container runtimes aren't really supported. And of course, it's an AWS-specific tool, so it is not cloud agnostic, and it's not, if you had built quite an ecosystem around ECS, that would not be easy to transfer to another cloud or potentially run in a sort of multi-cloud situation. And then because it's AWS specific, it doesn't have the extensibility that Kubernetes has. It doesn't have the kind of open source community that Kubernetes has. It's kind of limited that way. EKS is newer to Amazon. I forget, but I think it was first deployed or made available in 2018. And, that's the managed Kubernetes service. So there's a lot of advantages there. There is no control plane to manage. So that's a big advantage of EKS over, for example, running your own Kubernetes cluster in a data center. It is secure by default. It does have that open ecosystem that you can take advantage of. It's very extensible and it's built with the community, but it is fully conformant and compatible to Kubernetes standards. And then it is also another way to optimize for cost in terms of scaling up and down, running your containers in a cloud environment and taking advantage of all the things that a cloud gives you. And now just announced is Fargate's serverless ability to go with EKS. We're not going to speak about that here because that was literally announced days ago, and I don't know that anyone has a lot of experience with it. Limitations for EKS, of course, it does require Kubernetes experience. It's probably a little more of a learning curve to get up and running versus ECS. The service integration with AWS is still pretty new, and some things aren't fully supported or well supported or well documented. A good example is beta support for network load balancers. And then the ALB support is only via the ingress controller. And then, of course, the admission controllers, because the control plane is managed by EKS and not yourself, the admission controllers are managed by AWS. So that's kind of the overview of the two major options if you want to run your containers on AWS. And then we're going to talk now about how to monitor those containers and compare Amazon Cloud Watch, which is the native tool, and Prometheus Graph On, which is the kind of the open source community standard around Kubernetes. Jake, I'll let you talk about Cloud Watch.
Great. Thanks, Luke. So I'm sure most of you are familiar with Cloud Watch. It's been around for quite some time now. For those who aren't, Cloud Watch is a monitoring and observability service which enables you to collect metrics, set alarms, automate actions based on those alarms, either using predefined thresholds or machine learning algorithms like anomaly detection, which will examine over a period of time and adaptively react to anomalies that are detected. Container Insights was very recently released this year and provides high cardinality, granular monitoring, and metrics for either EKS or ECS. Since this is more of a Kubernetes-focused talk, we get cluster, node, pod, namespace level metrics, and it's incredibly easy to configure and consume. And as you'll see as we go through this webinar, one of the major advantages is that it allows for integration with traditional CloudWatch workflows, be they escalation and alerting chains, or perhaps even kicking off other pieces of automation. But one of the larger benefits is that out of the box, you can use the same solution to monitor both ECS and EKS, largely within the same dashboard and leveraging similar alerting capabilities. When we're looking, so the specific sub-product, if you will, is called Container Insights. Right out of the gate, Container Insights is incredibly easy to deploy. AWS provides a quick start, which is essentially just a bundled bunch of YAML, but it's a one-liner install that you replace your cluster name and the region. It does some sed in the background to fill out the YAML correctly, and it will deploy a new namespace as well as a Cloud Watch agent daemon set and a bundled FluentD daemon set. And there's optional StatsD integration if you want to toggle that on or off. By the same token, if you were to, say, already have FluentD in production, which most people who are running Kubernetes clusters already do, and you just wanted to continue to leverage the existing log flow collection that you have, you could just choose to deploy the CloudWatch agent daemon set with their provided YAML. Either way, it's very easy to do and highly configurable. It was just recently launched this year, so there are still a few regions that are unsupported in the typical AWS fashion. As I mentioned in the previous slide, we've got high cardinality data collection, pre-built visualizations and dashboards, the ability to dive deeper into that using CloudWatch Insights, and create your own custom dashboards based off those insight queries. Again, we can leverage standard CloudWatch alarms and notifications, and we'll show a small use case for that in a moment. While it is supported on ECS, it does not currently run for batch jobs, so that is one caveat. But we are able to use a single pane of glass basically to look at application, standard out logs and performance at the application level, performance of the overall cluster and nodes, gather logs around at the host level, important metrics around the control plane, so your Kubernetes scheduler and API, and then at the data plane as well, things like kubelet and the actual Kubernetes runtime. We are able to leverage CloudWatch alarms to perform EKS worker node autoscaling. This, to me, is an out-of-the-box benefit. Cluster autoscaler itself is not terribly difficult to configure. It's relatively easy. But with this, we can just simply set alarms. I have used in the past the node CPU reserved capacity or the node memory reserved capacity. And as long as you have an existing scaling policy to attach to that alarm, you're able to start scaling the cluster without having to do anything within kubectl. In terms of actually scaling pods themselves, you're still reliant on the Kubernetes HPA horizontal pod autoscaler functions that are pretty much a standard configuration. And so the one piece, in my opinion, that's still lacking, though apparently is on the roadmap, is the ability to scale your pods horizontally in accordance to an external action, that's consumed through CloudWatch. There is the AWS Labs developed K8s CloudWatch adapter. So with some advanced tweaking, we are able to scale pods horizontally based on external metrics from CloudWatch, but out of the box, it is not supported. So we've got a few screenshots just of what the type of visualizations that Container Insights provides out of the box. This is the node view, so we can see CPU utilization, memory utilization, and the reservations. Currently, these two, the two columns in the middle are what I typically have used for cluster autoscaling, standard disk and network, number of pods, and number of containers within those pods. This next slide, and I apologize, these are a little bit hard to view it at this size, but we can get out-of-the-box pod dashboards by mousing over any of the pod names or any of these graphs. In any of these dashboards, we're able to isolate a particular namespace, worker node, deployment, and view those metrics in much greater granularity. And then, again, we're also able to look at the overall namespace performance, and this is really handy if you are running, multiple environments or within the same cluster in any sort of multi-tenant fashion. These last two screenshots are just to illustrate how one might go about auto-scaling worker nodes based on a CloudWatch alarm. So with the provided node CPU reserved capacity, essentially we're saying that when we are hitting a threshold where we no longer have enough reserved capacity, I typically define that relatively high to not unnecessarily scale the cluster. But whenever we hit that limit, we can again just use the standard CloudWatch scaling action and choose the worker group auto ASG and a predefined scale up or scale down threshold to efficiently and easily scale the cluster. And this last screenshot is just a sample dashboard. Again, these are some of the out-of-the-box queries that AWS provides, but it's very easy to build custom dashboards that can show the number of times a container or pod is restarted, how many, if you have anything that has been requested and unscheduled, any node failures, things of that nature. And again, with the larger advantage here is the ability to integrate with existing alerting and escalation flows. So if you have some mission critical deployments and you want to be alerted every time the pod restart count goes over a particular threshold, it's very easy to configure within the standard CloudWatch GUI. And with that, I'm going to turn it back to Luke for the Prometheus section.
Yeah, thanks, Jake. So Prometheus is the open source community software solution for monitoring and alerting. It's pretty much become the standard for Kubernetes in terms of open source, and it is basically a time series database that records real-time metrics, and it's all built on primarily the HTTP pull model, which means that some type of metric gathering tool is deployed to wherever those metrics need to be gathered, and then that's exposed as an HTTP endpoint that you then configure Prometheus to go and gather those metrics on some interval. So the analogy that I've been using is to kind of explain it is your metric gatherer is like your electric meter, right? So it sits outside your house all the time, just slowly, exposing the metric of how much electricity you're using in your house. And then Prometheus is like the meter reader who comes around on some interval and reads the meter, marks it down, and can use that data over time to create a picture of how that metric is being used, in your cluster. Right, so to kind of talk a little deeper about how it works, metrics exporters are what expose metrics to Prometheus. The standards here that you always want to deploy, cAdvisor gathers your container metrics, and node exporter gathers your node metrics. And then Prometheus, because it's open source, because it's very extensible, if there's some other application metric that you care about for deploying your application, you can absolutely measure that and expose it as an HTTP endpoint to Prometheus, and then configure Prometheus to go and gather that metric. And it can really be absolutely any metric you choose. And the kind of standard way to do that is to expose it as a sidecar container in your pod. So, for example, if I had a web application that I wanted to measure, HTTP 400s or something from my web server, I would count those and expose that metric as a sidecar kind of service. And then configure Prometheus to go and find that service on the interval and pull that data in. All right, and so to talk a little more about how to deploy it, Helm is kind of the standard for Kubernetes in terms of deploying it. It is pretty easy to configure basic metrics and alerting with Prometheus. There's a lot of community resources in terms of how to do that. But, and this can be good and bad, there are a lot of knobs and dials that you can tune with Prometheus to gather custom metrics or gather metrics a different way, or, you know, determine the interval that you want to gather them on and that sort of thing. Most metrics, it says here all metrics are gathered via pull. That's not strictly true. I shouldn't have wrote that. But that is the standard of how metrics are being gathered by Prometheus. There is a push gateway where metrics can be pushed in if that's the only way it can be done, essentially for your specific metric that you want. And then because it is open source and extensible, alerting can happen through all sorts of different integrations, email, Slack, HipChat, whatever is the chat tool that your organization uses. Prometheus and Grafana are built around Kubernetes, and most of the community resources and the open source integrations and that kind of thing are built with the idea that you're deploying everything on Kubernetes. But definitely we want to touch on ECS because we're, you know, specifically talking about AWS. Definitely these things could be deployed and used in ECS. It would just take some good understanding of the tools and a knowledge of how they need to be run. For example, the metrics exporters that we talked about, which are standard C Advisor and Node Exporter, you would need to deploy those on your own into the cluster, whereas kind of with a Helm chart with Prometheus, that's going to all get deployed for you pretty easily. And then another important difference versus what Jake talked about is that scaling nodes or pods is not generally, the standard is not to do that based on Prometheus metrics. For pods, it's the horizontal pod autoscaler in Kubernetes, and for nodes, it's the cluster autoscaler. So, you know, we talked briefly about you could potentially scale nodes in your EKS cluster based on Cloud Watch metrics of some other AWS service. With Prometheus and Grafana, that's not really a use case that would be super easy to configure. And then another thing that we wanted to touch on briefly is you absolutely can configure Prometheus to gather metrics from multiple clusters. And that definitely could be useful in terms of measuring metrics and comparing, you know, for example, you may deploy multiple environments to separate clusters. But that would mean that you need to, because Prometheus needs to pull from HTTP endpoints, that means those HTTP endpoints need to be exposed to Prometheus in some way. All right. So we just have a couple screenshots here of Grafana. Grafana is just essentially the standard tool for displaying Prometheus data and can display data from a lot of different sources. This first one is just kind of a picture of container and pod memory usage, and you can see that we've deployed some pods that, you know, kind of go up and down to give you an idea of how that data gets displayed. Here's pod network IO, and this it's important to point out, you know, one big advantage of Prometheus and Grafana that we've talked about a couple of times is all the community resources, and all this dashboard is built, you know, with very little configuration off of just a community available dashboard that kind of pulls in those standard Kubernetes data. The third one here is just pod CPU usage. So you can see here which pods are doing that. And so, for example, if you're scaling pods with the horizontal pod autoscaler based on CPU, you would want to know, what are my pods doing? How, you know, what does the pattern of CPU usage look like, et cetera, like that. Cool. So we're going to talk about at least one customer use case where we've employed these tools. And Jake, I'll let you do that.
Great. So as I mentioned at the top of the call, the first customer reference is Your Call Football. Your Call Football offers football fans the opportunity to actually call plays in real time, i.e. End users are given choices of 3 different plays. The entire audience votes on whichever play they want the team to run, and those votes are then tallied, sent to the coaches. They call that play and are executed on the field by real players. And there's also a simultaneous streaming component where you can watch the game through the application, vote through the application, and even win cash prizes based on how accurate and performant your play calling is. I have been pretty terrible at it in the past. So as you can imagine, an application like this poses significant infrastructure challenges. The app has to handle both sharp, spiky bursts of traffic, but also needs to scale to a pretty large scale during the game and deliver consistent results. All of the voting tallies need to be compiled and delivered to the coaches. We have a 10 millisecond window to accomplish that, to ensure that the games run in a timely fashion. And so to ensure that Your Call Football could deliver on the application, we implemented Kubernetes via EKS, automated, with standard CI tooling, scaling and deployments through Helm. And from a monitoring and alerting perspective, we, in the past, have leveraged Prometheus and Grafana with Alert Manager to make sure that we get prompt notification of any trends or issues and provide real-time insights. But currently, as Container Insights has just been released this past year, we are running it in parallel as a POC because it does meet many of our core requirements and also presents the developers with an easy way to view the container logs that they're already familiar with as they're familiar with Cloud Watch. The second use case is a blockchain technology company. This company is looking to accelerate the adoption of blockchain technology in the gaming industry. The business is entirely microservices and Kubernetes based. It's a pretty interesting offering, allowing large games and indie game studios to leverage the blockchain for in-game transactions, as well as create sort of an economy around the game, so that people, when you're done grinding out 60 levels of whatever it is, you could actually, potentially sell some of the loot that you've acquired for an actual cash value for your in-game asset. Kubernetes was really the only platform choice from the start, given some of the design requirements. And so Mission has worked alongside with their dev team to architect and build all of the associated infrastructure, automate the deployments, and we've created several Container Insight dashboards and queries for both performance as well as logs to ensure that the devs can, again, quickly get access to the information they need without having to execute a bunch of kube control, log commands or anything like that. And we are currently leveraging it for auto-scaling instead of the traditional cluster autoscaler approach. And with that, I think we're going to throw it out to the audience for any questions. So when would be a better use case to employ Cloud Watch versus Prometheus? I mean, at the end of the day, they are both tools that accomplish the same factors. On the Prometheus side, you can get very granular and really tweak the heck out of it if you want to. And certainly, as Luke mentioned, there's a real broad community support for it. There's a lot of pre-existing Grafana dashboards that can be easily imported right out of the gate. I would say that in the AWS ecosystem specifically, that Container Insights does have the slight advantage of being much easier to integrate with the broader service ecosystem. As we showed earlier, we can use it to scale nodes, but we could also, choose to use that to scale a non-worker node EC2 auto-scaling group that might be providing, some sort of support function or an external, endpoint. So it's certainly easier to integrate with the broader AWS ecosystem, and I will say the ease of setup is not significantly greater because Helm install Prometheus is fairly simple, but it works right out of the box with minimal configuration. In terms of some of the common metrics that people want to look at for CloudWatch and Prometheus, I don't think that there's really going to be much of a distinction in terms of the actual metrics you're consuming. Everyone wants to know how their pods and deployments and their nodes are performing. So I don't know if there's too much of a distinction there. I will call out the reserved capacity metrics that we're currently using for scaling on the Container Insight side. That's something that's not quite analogous to Prometheus, but they're largely going to be a core group of the same metrics. And Luke, do you want to answer the third one? I don't want to hog all the time, but I'm happy to.
Sure, yeah, no problem. So do the monitoring tools work better with ECS or EKS? I think, talking about Prometheus and Grafana first, I definitely think ease of deployment, ease of use around EKS is way stronger because, that's what it's built around Kubernetes, and the community and tools there are built around Kubernetes. So I think I mentioned deploying that on ECS is definitely possible, but that's not where the bulk of resources and kind of community support would be. And then of course ECS is an AWS specific tool. CloudWatch is an AWS specific tool. So if someone was wanting to to manage their containers on ECS, I definitely think CloudWatch would be the go-to there first. And then I think Jake's point, I couldn't agree more about his point of the integration with AWS services for CloudWatch means that if you're using a lot of AWS integrated services already, Container Insights for your EKS cluster just makes a lot of sense to put everything in one place. All right. Well, I think that's all the questions. I imagine that we're not too hard to get a hold of on the Mission Cloud. If you wanted to ask questions of Jake or I specifically, we'd love to talk about it more. This is fun for us. And then missioncloud.com is also our website where you can learn more about us as AWS consultants. And thank you, everybody, for attending.